Hi folks, welcome to a Fusion Friday. We are going to show the beginner's cam to make the cam toolpath for this part back from Fusion Friday number 50 just a few weeks ago. Welcome to another Fusion Friday. So if you're an expert or guru, probably not the best video for you guys because we're going to take it pretty slow here. We're going to hop from model into cam. And in the cam, the idea is you're working left to right. So first thing we do is create a setup, then we create some toolpaths, and then we would post it out to our machine or to G-code. So I'll click setup. And I'm going to have some weird defaults here, guys. Sorry about that. Stock, the second tab here, I like to say fixed size box. We're going to actually input the dimensions, and we're going to say, let's say it's 1.5 by 1.5 by 2 inches tall. Now notice your coordinate system. Z is always pointed up or toward the sky. X should be pointed the other way right now. Z is up, Y is forward, so Y is backward right now. I'm going to click the tip of that X. See how I can highlight over that? Click once. That sets it correctly so that I'm going to sit on the machine. It's going to sit on the machine just like this, which is perfect. Now the one question is, where do you want your part to be in your stock? So we're going to hold it with a little bit of material down here on the bottom. This is a little bit too much. Let's say we were saw cutting it. So we could say reduce this to maybe 1.75. So I'm typing right here. But then I don't want the model or the part to be centered in the stock. So take a look. See, my model height, or stock height rather, is 1.75, and it has the position as centered. If I change that to offset from top, it puts in a default value that happens to keep it in the same place. I'll just say 0.05, and that's going to push the model up inside the stock. So really all we're doing now is just a quick cleanup of that top face. And this is perfect because that gives me more meat down here, which is exactly how I would make this part. I would use that extra meat here to hold the part in a set of hard jaws with parallels. So our setup looks good, and the most important thing, frankly, is understanding where this point is right here. Because when we are in the machine, we're going to use the top of the stock as our Z0. So we'll bring down a height gauge or a probe or a Heimer and find the top of our stock and hit that as Z0 in our controller like PathPilot. So I'll click OK, and that's now created our setup 1, which I'll call the top of block. So after we've got a setup, let's add some toolpaths. I'm going to go to 2D, the drop down menu here. Be careful if you're new to Fusion. Clicking the icons is sometimes not what you want, but clicking the drop down menu here will open up things like face. So facing is going to be an operation, and by the way, these pop-up windows are great. So produces a quick facing, to prepare raw stock for machining. So this is where you would use something like a face mill or a fly cutter. For me, it's tool 47. That's our Tormach Superfly. So I'm going to first select my tool. And if you don't have the tool that you want, you might click right here and just check all. That's going to basically wipe out the filters that are reducing the tools you have available to select from. So for me, it's tool 47. You do have to set up a tool library. It's a video that we've been looking forward to doing, and we'll put a card to that here when we have that published. But feel free to poke around on the forums or some of our other videos in the meantime if you're looking for help on creating a tool. Click OK. So we've now picked the tool, and in that tool library already had our speeds and feeds that we had put in earlier. So we're pretty much done with this first tab here. Geometry, we don't have to worry about, and in fact, none of the rest of these for facing do we really ever have to worry about, which is pretty awesome. So click OK and take a look. The colors do mean something here. So the yellow is a rapid move. So the tool's rapiding down, and then it's doing a green move, which is a linking move. So that's where the tool's now moving at a much slower feed rate than a rapid, but it might still be faster than your cutting feed rate. And as soon as it gets close to the part, it switches to blue, and that's your cutting, and then it goes back to a linking move out and then rapids up. If you're wondering why these are curved, it's because CNC machines do better when you don't ask them to take hard rights or hard turns. Just like you don't turn your car 90 degrees, you actually turn your car around a radius, even when you turn onto a street. So by having the machine swoop in like this, it prevents the machine from going down a complete hard stop and then a hard turn. So we've got that decked off. Simulation is your friend. This guy right up here, click it. There's two things that I like to change. I like they're already actually shown right here, but mode of tail and then turning stock on. If you hit play, this, by the way, down here adjusts your speed. And let's hit pause and let's actually turn off the tool for a second right here. And you can see it's showing the radius of that cutter. You're subject to the graphical limitations of simulation, is what going across this face and exposing. You can kind of see the CAD model holes right there. So let's add some drills. Drilling. I would probably spot these holes first. So I've got a spot mill set up here as tool. Actually, you know what? So the filter didn't come up. That's okay. I'll click right here and I'll add spot drill. That's something they should fix though. So 16 is my spot drill. Click OK. And under geometry, it's your second tab here. Hole faces. See how that's blue? That means it's the active thing. It's ready for me to pick the hole faces. So there are 4 holes here that I can spot. 1, 2, 3, 4. Now pay attention to what happened. It already gave us a live preview of the toolpath. And see how the green is going all the way down into the hole and through the hole? That's not okay. So all I'm doing here is spotting the hole. So on my third tab, which is the heights tab, don't get overwhelmed. There's a lot of noise here. Clearance height, retract height, feeds height. Ignore all of that. The two that I care about are the top height and the bottom height. So the top height is my hole top. What does that mean? That means it's looking at the top of this hole and it's saying that's where your hole actually starts. That's perfectly acceptable. What's your bottom height? Here's where this is a little bit weird. The bottom height for a spot, I'm going to set as the hole top. And right now that would mean your hole is 0 inches deep. Well, that's not okay. I actually do want the tool to go in a little bit. So I'm going to say from the whole top, but in this offset value, I'm going to put negative 0.05. That's going to push that tool 50 thousandths into the hole from the top of the hole. If that doesn't make sense, rewind this a minute and watch that again. I'll click OK. And I am a big fan of simulation. So I'm going to go back to the top of block, the setup here, which allows it to simulate all of these operations. Simulate. And I'm actually just going to fast forward or go to the end of the toolpath right here because I don't need to watch it. I just want to see what it looks like. Sure enough, I get 4 little dimples there. Perfect. I don't even know what this hole diameter is. Let's see if we can get a reading on that. So it's a 201 hole. So let's do this hole. Drilling. I think I've got this set up as a number 4 drill. Perfect. I got lucky. I already have it. Click OK. Second tab is geometry. So what is the hole I want to work on? Well, it's this hole right here. But this time we're not pecking or spotting. We want to drill this whole thing, and this is actually a pretty long hole. So under heights, it's got hole bottom. Does that make sense? Well, there's the whole top of my hole, and that hole is a straight hole all the way through. So a hole bottom actually does make sense, except remember, if we look at a drill tip, we'll edit this tool and show you, a drill tip has a point and then an angle. If you take a look, when we set that tool up, we measured the height, or the very tip of that as your sort of the height of the tool. So we need to actually poke this drill through further than what you see right here in order for it to actually clear the full hole. They luckily have thought of this already, and under heights, there's a formula here called drill tip through bottom, or checkbox. You just check. It automatically, see what it did there? Look at this green line when I uncheck it. Checking it, it adds it. I like to add a little bit of good extra, so I'll say 0.03 just to give us a little bit more push through. Now, unless you've got something crazy like a machine with through spindle coolant and you're using specialized drills and tooling, you're going to want to peck this. So that's the last thing here under cycle. I would change it from a drill that's just a regular drill that's going to push all the way through in one pass to something like a deep drill full retract. This is going to peck the drill every 50 thousandths. Takes a little bit longer, but a much safer way to drill, especially with a regular twist drill. If you do a lot of deep holes like this, look into parabolic drills. They're great for doing better chip evacuation. And I would do the same for these front 3 holes. Let's see what they are. 0.159. So, okay, we'll set up a tool because I don't have that drill modeled. So I will go to drilling. I will select my tool. But here we are, we're in this Brad part file. I click there once to kind of let me know I'm working in this Brad part of the tool library. You can see this plus icon right here. I'll click it, and that pops up my options. What's the type? It's not a center drill. It'll be a regular drill. What's the diameter? That's the top right, 0.159. And you would populate the length of it as well. I tend not to worry about some of this stuff here on the left. I do care about speeds and speeds. I don't know it off the top of my head, but I'll say 2500. And on a plunge rate, let's just say we go 10 thou per rev. That's a little fast. We'll say 5 thou per rev. Click OK. And so now I've added that. Let me show you one more thing. Right click. Edit tool, post processor. This is where you would set your tool number. So let's say that that's tool number 22. Click OK. And now I can pick tool drill 22. And under geometry, let's say you've got a whole bunch of holes that are the same size. I'll pick this first guy, and then under select same diameter, check that box, and it'll go through and automatically pick the other few. And the same thing, I want to poke these through a little bit more. We haven't actually machined this slot yet, but nevertheless, I want that drilled hole to be a through bore there when we are done. So I will just check drill tip through bottom with 0.03, and we're good to go. Save my file. So that's a very simple, let's do a simulation, a very simple face drill, face spot drill, I should say, operation where you can see along the simulation, it's going through here. It should poke through. Oh, it didn't poke through. I didn't poke through in the bottom, remember, because our model stops. Right now, it stops right at the top of that play button. Yes, I actually do this in real life when I'm testing things, but our stock goes a bit further down because of the parallels that it's resting on, and that's fine. I'll quickly show you one more operation, which would be, let's just do this slot. So that would be a new setup because we're actually going to take this part out of our vise. It's being held, sort of like this right now if we're looking down from the spindle of the machine. And we're going to lay it on its back to machine that slot. Oh, you know what? Let's do one more thing. I'm sorry. While we're here, it's a little bit of a tall part to cut this with with the side of an end mill, but for the sake of this example, let's show it. We'll do 2D adaptive clearing, and we'd have to pick a larger tool that would have enough strength. And this is, again, not really how I would normally do a part like this. I would probably normally machine all the sides of it, but we'll just take a look here. We would click this area here and for the chain, and under heights are really important. What's the top height? I have mine set as selection. Yours probably defaults to model top, and that's okay. And then the bottom height, I'll pick model bottom. Click OK. So again, just so we're clear, that says that the eligible area for this 2D adaptive to machine is from the top of the model, which is that area right there, to the bottom of the model. Click OK. Let's see what we get. Awesome. So it's going to come around. We're not going to get into what 2D adaptive toolpaths are in detail, but basically they're a way for it to understand and maintain a good chip load. We might want to do that in a couple of depths of cut. So I'll right click, edit, and under passes, fourth tab, I'll say multiple depths. Let's say we don't want to go down more than 0.3. Oops. And we'll click OK. One thing to note, adaptive toolpaths are not finish passes. They're roughing strategies only. So we'll show you how you do that correctly with this slot right here. I'll do new setup. But this time, we've got to move our work coordinate system. I also want to fix my stock, because let's assume by this point we've got our block sized correctly. So under stock, I would change from relative size to relative size box. Sorry, from relative size cylinder to relative size box. And under stock offset, I would say no additional stock. So basically we have a piece of stock that's exactly the size of our part. I would then go back to the setup tab, the first one, and orientation. So right now, it's inheriting the model orientation from the CAD when we made this part, which was that this face here was pointing toward the sky or perpendicular to Z. Well, we're going to lay the part down like this in the machine now, so I need to change that orientation. I'll click on model orientation and pick this first option, which is going to let me select my Z-axis. When I do that, these menu options here change. So Z-axis, what is my Z-axis? I'm going to pick this face right here and watch the blue arrow. See how it now pops to pointing up? It's exactly what I want. But my X-axis is flipped. So I'm going to click this line right here, or here would work as well, and see how that puts my work coordinate system triad correctly, showing that Y is forward and X is to the right. Awesome. One last thing though, where do you want that location point to be? I would probably, since we have this block machine to size, I would probably pick the top left corner, because that's where I've got my hard jaw and where I would be able to edge find. So I'm going to change from a stock box point to a model box point. And in this case, there is no difference between those two because my stock is the same size as my model. I still want to do this correctly, because if I change my stock later, I want to know, hey, I was still picking off a model point, which is that top left point right there. Click OK, and we've got our setup 2, and I'm going to call this the slot. So how wide is that slot? 0.26. So even though it's 0.26, I'm still not going to cut it with a 1/4 inch cutter, because you never want to slot, and you could do it with a 1/4 inch cutter, but that's a little bit tight. We'll use a 3/16. So I'm going to do 2D adaptive clearing. Pick a 3/16 tool. Tool 21 for me. Click OK. By the way, this file is available as well as copies of our tool library to anybody who supports our channel on Patreon. It's as little as a few bucks a month, and it helps us produce these videos. Second tab, geometry. So pay attention with 2D adaptive to what you pick. I could pick either the face, like this, or I could pick the lines. I generally prefer to pick the lines. So let's click this guy, and look what happens. It basically put a blue square all the way around here, which is okay, but I need to limit it. So watch, if I click this other line, it keeps me within that channel. What are my heights? Top height, I need to be model top, and again, that should be your default already on your computer. And the bottom height is selected contour. In this case, that's perfect, because that's the contour that I picked back here in the second tab, geometry tab. Let's just click OK. I don't like getting too far ahead of myself, because you want to see, make sure you get a toolpath before you worry about doing too much tweaking. So sure enough, that's an awesome adaptive toolpath, because it's going to avoid overloading the cutter. So it's going to take a bunch of swirly cuts. And it looks like it's long. We can take a look and see. Oops. Don't click clear toolpath like I just did. Machining time. You see that? If I right click on the operation, it's actually going to tell me how long that operation is going to take. 5 minutes and 33 seconds. That is way too long. So let's see what we can do about that. Right click, edit. Well, first of all, my speed's way too low here. we should be cutting at 1,000th per tooth. So that's going to almost double my speed. And then under optimal load, that's basically your width of cut. So what am I willing to do with a 3/16 inch end mill? It's 0.1875. I'd go a quarter of it. So rather than do math in your head, just type 0.1875 times 0.25. And we're going to leave radial stock. I'll come back to that, though. I bet you this will be a lot faster. Right click. Machine time, minute 46. Awesome. So because adaptive is not a finishing strategy, we have some radial stock to leave. What that means is it's not going to touch the very edge of this face, or basically it's not going to touch this face, nor is it going to touch that face. So what we need to do is come back with a contour to clean up those faces. 2D, contour, 1, 2, we should be done. If you take a look, it pulled in the last tool that we used, perfect. Our heights are already perfect. That's an error on my computer, don't worry about that offset there. Click OK. Awesome. If you wanted to run those a little bit further past, which I normally would or do, right click, edit. Under geometry, the second tab, tangential extension distance. That's a mouthful. I have no idea why it needs to be that complicated of a term, but say type in 0.2. It's going to push that toolpath on both directions past for good measure. Awesome. Folks, I hope you enjoyed. I hope you learned. Next week, we're going to do an advanced Cam Fusion Friday. When that video is published, we'll have a card here. Otherwise, I always appreciate your support and the thumbs up. Take care. See you next Friday.